Hello students, we have the question of trigonometry. So it is basically prove that question. We have to prove here left hand side equals to right hand side. I am gonna read the question first. 1 minus cos A plus cos B minus cos A plus B upon 1 plus cos A minus cos B minus cos A plus B equals to tan A by 2 into cot B by 2. So basically this is A by 2 is angle and B by 2 is here angle. Okay, so before I start to solve this problem, I am gonna write one very important formula that will be used here. So the formula is, we know cos 2 theta equals to 1 minus 2 sine square theta. Okay, so basically you are familiar with this formula. If you are willing to solve this question, you might have learned this one. Okay, so here cos 2 theta equals to 1 minus 2 sine square theta. This is I think you might be familiar with this formula. And in the same case, if there is just theta, like it is, if cos theta is only there, so basically this one will be like half angle formula. Okay, so 1 minus 2 sine square theta by 2. Okay, this both the formula are same. Simply difference is, if here is 2 theta, then we are using here theta, and if here is theta, we are using here theta by 2. From this equation, cos theta equals to 1 minus 2 sine square theta by 2, we can write it down like, bring this 2 sine square theta left hand side, 2 sine square theta by 2 equals to 1 minus cos theta. So basically now this is our one formula. We will be mostly using this one. Okay, and next one is also we have. So okay, let me write down the next one. Similarly, now again the cos theta formula is, we have 2 cos square theta by 2 minus 1. This is one is the also formula. So from this we can make our new formula, 2 cos square theta by 2. Bringing this one separately, writing it, we get cos theta plus 1. So now see here, we have got two formula, different formula. Basically these two formula we are gonna use here in the most of the steps. So this, you must remember and must be familiar with these two formula. 2 sine square theta by 2 equals to 1 minus cos theta, or 2 cos square theta upon theta by 2 equals to cos theta plus 1. So whenever we will find 1 minus cos theta, we can write 2 sine square theta by 2. Whenever we find cos theta plus 1, we can write 2 cos square theta by 2. Okay, so now let's start solving this question. So I am going solve it by taking left hand side. Solution, you must remember these two formula. Okay, this I have kept in the red bracket, these two formula. And how I have got this formula, you can see here. We have basically the formula cos theta equals to 1 minus 2 sine square theta by 2, and cos theta equals to 2 cos square theta minus 1. Okay, so basically I have got this formula from this parent formula. So now let's move to prove it. So I will write down the left hand side, 1 minus cos A plus cos B minus cos A plus B. So I am basically doing nothing, just writing the left hand side. Similarly, 1 plus cos A minus cos B minus cos A plus B. So now in next step, let's start. We will write the first term as it is, 1 minus cos A, nothing new. I am writing just same as it is, cos B minus, now look, cos A plus B. We have the formula of cos A plus B, cos A cos B minus sin A sin B. So that is formula of cos A plus B. So now we are going to apply the formula here in this point, cos A plus B. So cos A plus B equals to cos A dot cos B minus sin A dot sin B. I am keeping it in the bracket. Now let's give fraction. Similarly, in the denominator also, we are going to write the terms this up to here same as it is, and we are going to apply the formula here, cos A plus B. Okay, so nothing new. 1 plus, basically this question is like simplification. We are not going to use too much formula, just this one formula is here and one formula we will be using this. So this is a bit easy question, just we have to simplify it. Okay, nothing more complex here. Cos B minus, now cos A plus B is, we can write cos A cos B minus sin A sin b. You must not forget that here it is minus, so to open the bracket we have to multiply with it minus. So now let's move to next step, equals to 1 minus cos a plus cos b. Now to open the bracket multiply with the minus, so it will be cos a cos b, and minus will be plus, so plus sin a dot sin b. Now give the fraction here, 1 plus in denominator also cos, sorry I have here missed the cos a minus cos b, and now open the bracket by multiplying with the minus, so it will be minus cos a cos b plus sin a sin b. So okay, now let's start our main thing here. So look, basically I have written here, if we find 1 minus cos theta and if we find 1 minus cos theta and 1 cos theta plus 1, we can replace it with like 1 minus cos theta will be replaced by 2 sin square theta by 2. It is same like applying the formula in trigonometry. Okay, similarly if we find cos theta plus 1, we will be replacing it with cos 2 cos square theta by 2. So basically in place of theta there will be alpha, beta and whatever variable we have. Okay, so look here, I'm gonna underline with a red color. So wait, just let me write next step also. So basically here, wait, up to this term I have underlined with the green. This is our, okay, so here we can apply the formula 1 plus cos theta, sorry 1 minus cos a. Similarly 1 minus cos theta or 1 minus cos a we can replace with 2 sin square alpha by 2. Okay, similarly here also we can replace it with 2 sin square alpha a upon 2. Okay, so in this term we are going to take the common. Okay, so in these two terms we are going to take common. Let me underline with here up to this term we are going to take common. So here we will take common of cos a. So let me write the next step. So leave it 1 minus cos a as it is and take the common of here cos beta. So it will be remaining with 1 minus cos a plus sin a sin b. Give the fraction. So basically you should write the equals to at the middle, that will be okay. Similarly in denominator also 1 plus, take the common in this term. Okay, so here also we can take the common of cos beta. So it will be left with 1 plus cos alpha, because here it is common of minus cos beta. Okay, so you must not be confused upon with the sign here, so you must be aware. Okay, so remaining term will be sin a dot sin beta. Okay, so now it is very easy, just we have to here apply the formula. So basically you can write down in the copy, in place of, look here, in place of this 1 minus cos a, 1 minus cos, we can apply this formula. Similarly in this place of 1 minus cos a we can apply this formula. Similarly in the place of 1 plus cos a we can apply this formula. Here also we can apply this formula. Okay, that is our main thing, nothing complex here, we are just simplifying it, and the most prominent thing is that using this equation, trigonometric formula. Okay, so we have got, now let's solve it. So in place of 1 minus cos a, what we can write, 2 sin square a upon 2. Similarly plus cos b, it will be as it is, and in this bracket what we can write here, 1 minus cos a, we will be writing 2 sin square a by 2. Okay, and this term will be as it is, nothing change here, sin a dot sin b. Now give a big fraction here. In denominator, in place of 1 plus cos a, what we gonna write, 2, okay, change the color, 2 cos square a by 2. Similarly minus cos b as it is, in place of 1 plus cos a we are gonna write 2 cos square a by 2. plus sine A dot sine B, it will be as it is. So now right, next step. So in this place we can take the common. Now look here, just wait. In this two term we can take the common of 2 sine square A by 2. So okay, similarly in this two term we can take the common of 2 cos square A by 2 and leave the remaining term as it is. Okay, so now let's see. I will be taking common of 2 sine square A by 2, and this our remaining term will be 1 plus cos beta. Okay, don't use that bracket. 1 plus cos b. Okay, so in this term, if 2 sine square A by 2 is taken the common, then what will be remaining? 1 plus cos b. Similarly, we have this last term, sine A dot sine b. Now I am giving you the big fraction here. Same thing we will be going to do in denominator also. We will take common here 2 cos square A by 2. So after taking common of 2 cos square A by 2, what will be remained with 1 minus cos beta, sorry, cos b. Okay, so this is not actually alpha beta, this is actually A and B variable. Sorry, sine A dot sine B. Now our again here also we are going to do same thing. In place of 1 plus cos beta, we are gonna write 2 cos square beta by 2. In place of 1 minus cos beta, what we are gonna write? 2 sine square theta by 2, same as above. Okay, just apply the formula again, apply the formula here, nothing more. Now here also we are gonna write 2 sine square A by 2. In place of 1 plus cos b, what we are gonna write? 2 cos square b by 2. We are, how we are going to write, because we have already here shown it here. This is the way we are writing. Okay, so focus on solving. Now up to this term we will solve. Okay, now this term sine A and sine B. What is the formula of sine 2 theta? You are familiar of this formula. Let me write here. Sine 2 theta equals to 2 sine theta cos theta. In place of sine 2 theta, if it is only theta, then we are gonna write 2 sine theta by 2 and cos theta by 2. Okay, same thing we are gonna do here. Okay, I am erasing it. In place of sine A, we are gonna write 2 sine A by 2 dot cos A by 2. Similarly, in place of sine B, what we are gonna write? 2 sine B by 2 dot cos B by 2. Okay. Similarly, in denominator also, what we are gonna write? 2 cos square A by 2. In place of 1 minus cos B, we are gonna write 2 sine square B by 2 plus, in this term what same thing, sine A. In place of sine A, we are gonna write 2 sine A by 2 cos A by 2. In place of sine B, we are gonna write 2 sine B by 2 upon cos B by 2. Okay, 2 sine A by 2 dot cos A by 2. In this question, basically we are just using very simple formulas, and the difference the top it makes is like simplifying a lot. Okay, so that is the main thing here we are facing the problem. So sine beta B by 2 cos B by 2. Okay, so afterwards, now what we're gonna do here is we are going to take the common. So what will take the common here is, okay, so let me show you. First, just simplify it. It will be like 2 sine square A by 2. It will be like 4, nothing more, sine square A by 2. I'm not doing nothing complex here, just multiplying this constant 2 into 2. Okay, so sine square A by 2, that will make our expression easy to take the common. Similarly in there also it will be like 4, here nothing to do, sin a by 2 dot cos a by 2 dot sin b by 2 dot cos b by 2. Okay, draw, give the big fraction here. Here also 4 cos square a by 2. I am doing nothing new here, just I am multiplying with all the constant terms, 2 into 2 4, and writing the remaining terms as it is. Okay, so 2 into 2 4 sin a by 2 dot cos a by 2 dot sin b by 2 dot cos b by 2. Okay, equals to, now we are going to take here the common, so the common will be our like sin a by 2 cos b by 2. So what common we are going to take here? 4 sin a by 2 dot cos b by 2. In numerator we are gonna take 4 sin a by 2 dot cos b by 2 common, so remaining term will be here. If sin a by 2 and cos a by 2 common taken, then remaining one term will be like sin a by 2 dot cos b by 2, and here what the terms are taken as common, sin a by 2 is taken as common, cos beta by 2 is taken as common, so remaining term will be our cos a by 2 dot sin b by 2. Okay, so right, cos a by 2 dot sin b by 2 is our common. Now give a big fraction here, so I have given a big fraction, and now here also what will be the common, 4 cos a by 2 sin b by 2. So 4 cos a by 2 dot sin b by 2 is our common, and after taking the common, what will be the remaining term in this first case, it will be like, if one term of cos a by 2 is taken and one term of sin b by 2 is taken, then remaining will be our cos a by 2 dot, it is nothing complex here, just taking the common, plus, now here what are the things taken as common, cos a by 2 is taken as common and sin b by 2 is taken as common, these two, and remaining will be our sin a by 2 and cos b by 2. Okay, so sin a by 2 dot cos b by 2 is our remaining term. So now let's move to next step. Here look here, sin theta upon cos theta is our cot theta, cos theta upon, sorry, sin theta upon cos theta is tan theta, cos theta upon sin theta is our cot theta. So okay, so here this 4 will be cancelled, and this sin a by cos a, it will be our what, tan a by 2 dot cos theta upon sin theta, it will be like cot beta by 2. Okay, in place of theta we have beta b by 2, so we will writing b by 2. Now solve inside the bracket term, so this actually this two term is solved. Now remaining it will be our what, into sin a cos b plus cos a sin b, so this will be our what, sin a by 2 plus b by 2. Okay, upon here cos a sin a cos b plus cos a sin b, this is also same formula, sin a, in just the difference is in place of a, here it is b by 2, so it will be our, actually this a by 2 we can write sin b by 2 plus a by 2. Okay, so basically these two are same thing, tan a by 2 dot cot b by 2 into what will be our this term, sin a plus b by 2. Similarly here also sin a plus b by 2. So basically these two term are will cancel. Okay, so remaining term we will get equals to tan a by 2 dot cot b by 2. Okay, so this is our right hand side, hence proved. Okay, this is how we are gonna solve this. Thank you very much.